Okay, hello. I'm Zian from Mesa. I am a BC, well, I was a BC kid, and we're gonna do a derivatives very, very basic lesson because I find that as someone who didn't really had a good grasp of the basics, I had struggle answering complex questions based on derivatives and also answering word problems, things like rate in, rate out. And I think it's really important to understand like the core ways to solve derivative equations because BC and AB will throw a lot of different things at you, crazy equations, combine different derivatives, and you get like a really big equation. And I will show you all the last part, which will be chain rule. And this is really basic. And a lot of folks you may or may not believe it. I struggled a lot with some things, even as far as notation, not necessarily derivatives, but with other different things. And so we are going to start with the basic notation because believe it or not, some people will also look at like the second derivative and they might think that it's a third derivative. So I think it's really good to first clear up some of the first things that we encounter, which is notation. So obviously we know that f of x is the original function. And when they ask for what is the first derivative of f of x, it is written as this way, f prime of x. It can also be asked as y prime. And keep in mind, it could also be asked in different, what do you call this? In different variables. So you could have g of x, and they're going to ask which g prime, what is the first derivative? So g of x. And then they could also ask what's h of x and what is its derivative. So it would be h of x. So these are just the different ways. It is also imperative to realize that there is not the AB and BC will not only ask about the first derivative, they can also ask about the second derivative. So this will be written as follows. F of x, the second derivative, is f double prime of x. G of x double prime of x. Okay, and then the third derivative, it can be written as such. F of x to the third derivative. And then it can also be written as such. F to the third. That is different. This is not the same as f of x to the power of 3. This is looking for the third derivative. This is squaring the whole function. This is squaring x to the power of 3. So let's give it a test run. What is the second derivative notation of g of x? Well, the first derivative notation would be g prime of x. And then the second derivative notation would be g double prime of x. So that is fairly simple. I know it's such a simple thing to go over, but believe it or not, like I said, people will mess up on reading a question and thinking that it is, they might freak out and see, oh, what does this mean? Well, that just means the fourth derivative. So getting yourself familiarized with what they are asking for and how they're going to ask for derivatives is really imperative. So that is the most simple thing that you can get like incorrect in, okay? So what exactly is the purpose of a derivative? Now, we are not going to get into like the applications of derivative and like real things in this lesson, but I want you all to start looking at derivatives in this framework. So a derivative is used to find the rate of change of the quantity with respect to the other quantity. So that is very important. In other words, recall that rate of change is slope, the change at a specific point. So that is this formula. So you can actually use the derivative to find the slope. Now, one of my peers might do something of that sort, rate of change, and using tangent lines, slopes, etc. In this lesson, we will not be going over that. We will be going over the different ways you can solve derivatives. Okay, so derivatives in action. All right, let's not freak out. This is going to be extremely easy. Okay, so the first example is 6x to the power of 3 minus 9x plus 4. So how would you solve this? Well, you see these powers? Well, all you have to do is reduce it. You have to subtract it by 1. And you would also have to subtract all of this by 1. And this is 0. So this does not exist. Okay, so now that you have to keep that in mind, you have to realize that you have to multiply the exponents to the coefficients. So this would mean f prime of x is equal to 18x. So 3 minus 1 is 2 minus 9. Okay, Zian, what happened to 4 and the x here? Well, keep in mind that negative 9x is negative 9x to the power of 1. When you subtract negative 9x, when you subtract x to the power of 1 minus 1, you get negative 9x to the power of 0, and then this will become the coefficient. So keep that in mind. And remember that this does not have a coefficient. So the way I remember it is the fact that any term that has a number that is constant number, it will be equal by itself, but it will not go to the equation. So let's say x plus 4, right? We know that it's x to the power 1 plus 4 to the power of 0. And that will equal to 1, because this goes here, minus 1, and then this is just a constant number. Okay, so that's pretty simple. The next example is quite tricky because we are dealing with negative numbers, negative exponents, let's say. It's actually not that hard. You know how to do math. You've all been to algebra 2, and you did pre-calc, or you're currently in calculus. Well, let's see. Well, this would be solved as such. Negative 4y. Okay, remember, you are subtracting. So negative 4 minus 1, plus 27, because negative 9 times negative 3 is positive 27. Y, negative 3 minus 1 plus 8, not 8, sorry folks, negative 16y minus negative 2 minus 1. And then you know that this is a constant. So what do? You don't do anything. You don't add that to the derivative. So when you keep these in mind, when you do the subtractions in the exponents, you will get negative 4y to the power of negative 5, because negative 4 minus negative 1 is negative 5, plus 27y to the power of negative 4 minus 16y to the power of negative 3. Pretty simple, right? So that is your answer. It's not that difficult. When you first get these basics down, it's really easy to start doing derivatives. So what are some of the things you need to remember? Well, keeping in mind that when you have x squared plus x minus 3, you would have to do the following. You multiply exponents as a coefficient, 1, and then 0. And such, you will get 2x plus 1. And then keeping in mind that constant numbers like 4, 3, 2, 1, and e and pi does not exist in the derivative. So this would be your answer to this example right here. Okay, so that's pretty clear so far. It's really easy, and then it will get tricky. The next part is derivatives of trigonometric functions. Trig functions, I will say, you just have to memorize it. Like straight up, you just have to memorize it because there is no way for you to remember. Well, there's no way for you to do the math behind derivatives. You just have to remember it. So pretty simple. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent x is secant squared x. And then the derivative of cosecant x is equal to negative cosecant x times cotangent x. And the derivative of secant x is secant x times tangent x. And the derivative of cotangent x is equal to negative cosecant squared x. So I have a big advice for you folks in Daides class. You will need to memorize these trigonometric functions because AB will be heavy on testing you on these concepts. There will be questions that are straight up just trig. It will just literally be like d dx and then cosecant, what is going on? Cosecant x. Daide will literally probably give you a quiz on just trigonometric functions, and you will need to memorize it. It is critical that you make flashcards. It is critical that you go to Quizlet because I did not do that and I did not have fun with my grade. So please memorize these trig functions. So let's do a couple. And it's okay if you probably will need to reference this paper because you will not immediately memorize it. But as you start doing more practice on this, I want you all to really challenge yourself to not look at the paper before the quiz that Daide might give you. I want you to keep referencing it so you have accuracy and then eventually wane off from using the paper. How did you memorize the pi, the unit circle? Well, you had to memorize it. You created systems. You tried to really study for it. So I want you all to please memorize the derivatives of trig functions, especially in AB, and you will especially need it for BC too. So what is the derivative of tan x? Well, we know that the derivative of tan x is secant squared x. Okay. So what is the derivative of cotangent x? Well, we know that is negative cosecant squared x. And what is the derivative of secant x? Well, the derivative of secant x is secant x times tangent x. So I hope that we are clear on that, but please listen to my advice when I tell you all to memorize these derivatives of trigonometric functions. Okay, derivatives of ln. It is pretty simple. So f of x is equals to ln of x. Well, the derivative of that is just 1 over x. Repeat after me. F of x is ln of x, and the derivative of ln of x is 1 over x. Okay, it's pretty simple. You just have to memorize the formula for it. Now let's do a little bit of challenge right here. So ln parentheses x plus 1. I have not taught chain rule yet, but this is sort of like chain rule. Okay, folks? So this would be ln of, well, the derivative of ln. So that would be 1 over x plus 1 times 1 will equal to 1 over x plus 1. And that's it. Well, the reason why this is not some crazy formula is the fact that you have to find the derivative of this, and you also have to find the derivative of this, and then multiply it, and you multiply the derivative. So times 1. That would be chain rule, which I will be segmenting us to the next part. Okay, so what about this one? This is also chain rule. It would be ln of x to the power of 4. Okay, and then you know that it is 1 over x to the power of 4 times, well, what is the derivative of this? We know that the derivative is 4x to the power of 3, and you multiply it, and it's 4x to the power of x to the power of 4, and you do the math, and you get 4 over x. So that is the answer. Now you're wondering, what is all these parentheses and all that crazy stuff? Well, I will be going over chain rule after we look at derivatives of roots. So how in the heck are you supposed to write the derivative of square root of x? Well, you can rewrite this as such: x to the power of 1/2. The square root of x is equal to x to the power of 1/2. These are both the same. Now, what have we been doing? We've been subtracting exponents by 1. So, and then multiplying the exponents as the coefficients. So 1 over 2. Well, the derivative is equals to 1 over 2 times x to the power of negative 1/2. And that is your answer. And if you want to simplify it, it would be equal to 1 over 2 square root of x. Okay, now cube root. So still the same. The equivalent of cube root of x is x to the power of 1 over 3. And f of x would be equal to 1 over 3 times x minus, well, what is 1 over 3 minus 1? Well, that would be equal to 1. Well, that would be equal to 3 over 3, and that's negative 2 over 3. So negative 2 over 3. And that is your answer. Okay, the famous chain rule that I have been talking about simultaneously. So this is chain rule's formula. We have f prime of x equals f prime of g of x times g prime of x. So you find the derivative of f of x, and then you keep this the same, and then you multiply it by its derivative. Okay, it makes sense once you see it in action. So sine 4x, sine times 4x. Okay, remember, the derivative of sine is cosine of x. So what we're going to do is we're going to find the derivative of sine and keep g of x. This would be your g of x, and this would be your f of x, right? So then you would find the derivative of f of x. So that would be cosine of, you keep what is inside, which is g of x, the same, 4x, times the derivative of 4, which is g of x in this case. So that's 4. And this will equal to 4 cosine of 4x. So I want you all to visualize this particular formula. This would be f prime, and then this would be g of x. And then this would be times g prime of x. So that is the same exact thing as the formula. Perfect. Now let's try this very, very simple one. So we have this function. So g prime of x would equal to, what did we do? What did we say we do? Well, we multiply the exponent minus 1 right here. So that would be 3x plus 1 to the power of 4. Oh, but you're not done. Remember, there's something inside. So the derivative of 3x plus 1 would be 3. So then you would get 15, because you're multiplying it times this, 3x plus 1 to the power of 4. Perfect. So now that is chain rule. You will see a lot of chain rule questions in, you'll see a lot of derivative questions in AB, chain rule especially. So it's very important that you try your best and remember this formula. Okay, product rule. So product rule is extremely interesting. You would have to have this equation, and you would do the following. You would divide it into these. So you have f of x. So this would, let's say this is f of x and this is g of x. Okay, so you'd find f of x, and that would be 3 minus x squared. And then f prime of x is negative 2x. And then g of x is x plus 4, and g prime of x is equals to 1. Okay, so now keeping this in mind, we will plug in the following that we found, the variables. So let's start with f of x. So 3 minus x squared times 1, which is g prime, as we said here, plus, well, what is f prime? Negative 2x, and then g of x, x plus 4. Now, you can leave it at that or simplify it, but I would try to simplify it. So this would be 3 minus squared plus negative 2x squared minus 8x. Okay, so then you would get, well, what is negative x squared minus 2x squared? That would be 3x squared, okay, minus 8x plus 3. So this would be the answer. Perfect. Now, quotient rule, which should be fun. Well, quotient rule is pretty much similar to product rule, where you have to plug in a bunch of equations. So remember this equation: g of x times f prime of x minus f of x times g prime of x over g of x to the power of 2. So we have this. We will divide this up into f of x, and that would be equal to 5x plus 1, and f prime of x is equals to 5. And then g of x is equal to 3x minus 4, and g prime of x is equal to 3. Yeah, 3. That should just be 3. Perfect. Now we will plug in it in the formula. So what is g of x? Well, 3x minus 4 times, well, what is f prime of x? 5 plus negative minus f of x, which would be 5x plus 1. Well, this is not plus, it would be minus. Sorry, folks. Minus, where was I? Oh, g prime. So 3, and then 3x minus 4 squared. Okay, perfect. So we do the following. 15x minus 20 minus 15x plus 3. Okay, 3x minus 4, and then you get the following. You cancel these out, combine like terms, negative 17 over 3x minus 4 squared. So that is product rule. And that will be it for today. So keep all of these rules in mind. Remember the formulas, especially for trig, and also remember the formula for product rule and quotient rule. Those are the ones that you really need to remember because I feel that they come up a lot. DIDA might also ask straightforward questions regarding those. So yeah, I hope you guys find this review very helpful. I wish you the best of luck in your AB and BC test. Thank you. How do I